So, welcome everyone to 2021 session on eight previous year civil engineering questions. Today we will be discussing on the topic of fluid mechanics. First question will be based on boundary layer, basically a formula based question. Second and third questions are a little bit, yeah, they also need a knowledge of theory, but they are very basic kind of questions, so you don't even need to know a lot of formulas for them. Just some basic knowledge, which I think we have had we take second year itself. So let's start. First question, GATE 2008 question number 53. The flow of water mass density is equal to 1000 kg per meter cube and kinematic viscosity is equal to 10.6 meters square per second. In a commercial pipe, the equivalent roughness Ks of 0.1 mm gives an average shear stress at the pipe boundary of 600 Newton per meter square. The value of Ks divided by delta star is where delta star is the thickness of the laminar sublayer. So let's solve this question. Basically, there are a few assumptions that we need to know about. The main formula that you must remember to use this equation is that V star friction velocity into or the shear velocity and multiplied by the thickness of the laminar sublayer divided by the kinematic viscosity is a constant number 11.6. Something you need to know. And another thing that how do we calculate this shear velocity? So that is V star is equal to downward by right, because with the downward is nothing but your shear stress and is the density of your. So with this formulas we can easily solve this one. Let's see. So to get this k by delta star, we need the value of delta k. K is already given to us, right? And delta we can calculate using these equations. Let us see what is the value of V star first. V star is going to be better delta by rho, right? So we are given the delta, downward by rho. Downward value is 600 Newton per meter square. And rho is 1000 kg per meter square. So square root of that, that is simplified with also simplified and so I apologize for this bad handwriting. Very correctly, I don't know if you can tell from the voice. It's shaking, so it's difficult to write. Again, you know the reason I told you in previous videos that cannot afford to postpone these classes because of the schedule or between all the materials, college and NPTEL. So we have to make do with whatever situation we are in. And also the last two sessions, we have been asked to take 2 hour sessions. So if we, what I am going to do is I'm going to take two 1 hour sessions because 2 hour altogether is tedious. I don't think so that you guys will also be able to pay as much attention for a 2 hour continuous session. So what I'm going to request to the NPTEL team is that we'll take 1 hour session on Sunday as usual and maybe 1 hour session on Monday. So getting there parity of that. Alright, so now let's come to the question. Again, I will so you feel that writing is important and like this is to write. So once you know this shear velocity, you can substitute this into this formula, basically which is derived from formulas. First is the Reynolds number, and you have E by mu, and your formula for the shear stress, that is mu EU by E. So, and also the commercial pipe, we know that it is a linear relation between. So we can approximate the derivative of this velocity with the call as u by y. Right? So we use these two kind of formulas along with the v star as you can down on arrive at this arrive at this. Alright, so I'm going to leave it there for you to try out. We'll see. So once you get the shear velocity formula, you can just substitute this into this delta star, and you are going to get something like this, where mu is the kinematic viscosity which is given to us in cos minus 6. Okay, so let's look back at this question again. So we calculated our V star as 0.6. Then we use this V star to get the value of delta star using this formula, right? And you substitute the values of your delta star, sorry, your V star, and tilde, and you mu is the friction parametric viscosity into this formula. You are going to get it as 1.4 something, right? We can write do that calculation, and then what we can use this to calculate value of ks by tilde. So your ks is given to you as 0.12 mm, is going to be 0.1 meters divided by your tilde star that we have calculated 1.45 into 10 power by 0.150 divided by 0.0 equal to 8. That is the answer. This question. So I hope you are able to follow this. Again, I apologize for all the disconnectivity. I am trained, as I told you, that is very difficult to get a stable internet connection. Let's go to the next question. Alright, so this is the second question for today. Case 2008, question number 82. An automobile with projected area of, so A is given to us. Okay, an automobile with projected area of 2.6 meters square. So we know 2.6 meters square projected area. So the area that comes in contact with the field, and it moves at a speed of 120 kilometers per hour. 120 into 5 by 18 per second. Mass, density, and the kinetic viscosity of the air is given. So we have the density of air as 1.2 kg per meter cube, and the kinetic viscosity is 5 to 10 power 5. Alright, so we'll come back. Yeah, so we have seen all the variables that are given to us. The drag coefficient is 0.3. Now what is asked of us is the drag force, which is very easily, I think you all remember this formula. CdA rho V square by P. We just have to use this basic formula. This is the formula which also we use to get the terminal velocity of air when it is falling through internal velocity of the water droplet when it is falling through the air. So you can easily use this formula to get the drag force. I'm not going into the derivation because already we have very unstable internal connectivity. I don't want to make it more complicated. So let's see. Let's put in the values. CD 0.3 dimensionless, A 2.6 meter square area. The density of air 1.2 kg per meter cube. The velocity is 120 into 5 by 18, and then we do the square of that divided by. Alright, when you substitute the values in this formula and you calculate, you are going to get nice even value of 520 Newton as the answer. That is the drag force. So the correct option is B. See, so it was not a, it was a very basic question, the very basic formula which I think everyone uh, in civil engineering should. Now we have a second question. So it's a two-part question basically. So this second question, I like this question because it also makes us remember one crucial relationship between horsepower and wattage. So let's see this. The theory part is the same. We have an automobile with a projected area of 2.6 meters square running on the road with a speed of 130 km per hour. The mass density is the air is given as 1.2 kg per meter cube. The viscosity kinetic viscosity is 1.5 meters per minus 5 meters square per second, and drag coefficient is 0.3. Now, when you know this, the question is asking what should be the horsepower of this vehicle so that it is able to move forward, so it is able to overcome this drag. So, yeah, so let's see. So, when we have the drag force as 520 Newton, the power required to make this force right is given as P is equal to, so it's given as P is equal to F the into the velocity with which the vehicle is moving. So we have 520 into 120 into 5 by 18, the velocity with which the vehicle is moving in meter per second. And what unit are we going to get? Newton into meter per second. So Newton meter you can say as work per second is going to be the unit to convert that work into watt. So this is the unit of watt, right? Newton meter per second. So 520 to 120 into 5 divided by 18, we have the value as 17333.33 watt. Now the relation that you must know now after this to solve this question is 1 horsepower is equal to 725.5 watts. Right, so you should know this particular equation relation to solve this. Now, once you know this, the horsepower is nothing but P divided by 735.5, which is equal to 23.56 horsepower. So the closest option to this our solution is option C. So we are going to assume that C is the correct answer. All right. So that's all for today's session. And I know it was a very weird session because there was a lot of internet connectivity and disconnectivity. So if you tried to join and they couldn't join, then I think I couldn't know I couldn't figure that out, so I apologize for that. But I hope you can see the recording and you'll get something out of this session. So we have discussed three questions in this session. First question is related to boundary layer, which I think you should definitely go and check out because we are discussing some of the assumptions which are important in the boundary layer when it comes to gate. And the remaining two questions were very simple questions, formula based and theory based questions. So, yeah, so that's all for today's session. And we'll meet again on Monday. So I'm going to take session on Monday, that is tomorrow in the evening for the session week 19 that I missed out. Hopefully, I will be in IIT that time, so I'll have a very stable connection, and we can have a much more fruitful interaction during that time. All right, thank you, guys.